Hello, and on behalf of VMUG, I'd like to welcome you to today's webcast event. Today, we have two webcasts running back to back. The first is Easy Button for Modern Apps from Dell and VMware, presented by Kenon Ewing, VMware Business Development Manager, and Itzik Reich, VP Technology. And our second presentation is titled Better Together, VMware Cloud Foundation with External Storage, presented by Ian Breitner, consultant, Dell EMC Storage Solutions. Thank you for participating in today's webcast and for your continued support in the Global VMUG program. Before we begin, I have three quick housekeeping items to go over. First, today's webcast will be recorded and available for you on demand. You will receive an email with the on-demand link, so keep an eye out for that. Second, a Q&A session will follow today's presentation. All questions will need to be entered in the question window near the bottom of your GoToWebinar screen. And third, there will be a short online evaluation that pops up as you exit the webcast. Please take a minute and let us know what you thought of today's session and what you might like to see going forward. All attendees from today's webcast who opted in at registration will be entered into a raffle to win a Nintendo Switch Lite. The winner will be contacted directly by Dell, so good luck. All right, let's get started. Itzik, I'll turn it over to you now.
Thank you very much, Julie. All right, so everyone, good morning, good afternoon, or maybe even good evening, depends on where you are in the world. I'm very excited for this webcast because it's, I think, the first time that we publicly talk around the ecosystem integration when it comes to VMware Tanzu, Kubernetes Grid, and the Dell EMC portfolio. So with that, let's start. When you think about the workload evolutions of how VMware really started, right? Before VMware, there were the bare metal servers. Each one of them ran its own operating system and an application. Then came VMware and started to consolidate everything into some massive E6i host. Then came Docker in 2015 and said, maybe there's even a better way to do it. Why don't we install an operating system without an hypervisor? At the time, probably a Linux operating system. Fork the kernel of that operating system, and each one of these forked kernel instances will run its own application. And the way to fork the kernel was basically to use the Docker runtime, which is the magic behind slicing and dicing the application that ran on that kernel. And some customers are actually doing this today. They are going with bare metal virtualization, just put the Docker runtime on the top of the bare metal OS, and that's it. However, there is also a new emerging use case that some may argue is not that new and actually is the dominant one. If you talk about the cloud providers, they still install an hypervisor layer on the top of the bare metal. And either the fact that they can fork the hypervisor itself and install the Docker runtime engine on it directly, or they spin up a VM and they fork the OS kernel of that particular VMs. And all of these approaches are super valid, right? If you provision a container from the large service providers, it's not just running on bare metal server. There is an hypervisor there. It can be an E6 one like vSphere on AWS, but it can also be other operating systems. So many ways of basically running containers today. If I then switch to the storage management, what did we do up until Docker came into this world? Well, we probably use the UI of the storage interface. What you see here is the user interface of our PowerFlex storage array and software-defined product. And very easy, very slick to use, but it's a UI. You need to sit in front of the screen and actually work with it to do things. And the way to automate things in the old world was probably using some sort of a CLI or REST API, like you see on the lower part of the screen. That was the way to automate your storage basic provisioning operations. But if we then move forward into the new world, what we are starting to see is that customers are starting to get fixed on automation frameworks. For VMware audience, probably you're very familiar with the vRealize operation or an orchestrator and vRealize automation that can run on the top of vRealize orchestrator. And that's very useful, especially for the traditional use cases as well, even regardless to containers. Some may remember the previous effort by OpenStack. We used to have this thing called a CIF plugin that does all of these storage provisioning operations as well. And some other plugins still exist today and are actually being very heavily used, like Ansible, and many of our customers are actually using Ansible today to automate their storage operations. But then came also VMware into this world with their VMware Tanzu Kubernetes Grid offering, which wants to basically take control of the entire end-to-end relationship from the developer to the operator when it comes to managing containers. And we offer plugins, by the way, for all of our major platforms, for all of these various types of plugins that do find in our customer install base. Having said that, people are also looking to automate not just their provisioning operations when it comes to storage, but also the monitoring aspect. They don't want to manually be alerted every time an HBA goes down or when they reach out of their full capacity of their storage array. They want to be proactive in that manner. And for that, we also have the software that manage everything externally when it comes to infrastructure, known as Cloud IQ. It's basically give you an holistic approach of, for example, when are you going to run out of capacity based on your current trajectory? Or, hey, you connected your HBA wrongly and so far so good, but if that HBA goes down, the server goes down because it will lose access to the storage. So again, people are looking to automate those things. They don't want to manage and monitor their storage array like they did in the old days because the data growth is growing and growing. And in the context of containers, there is even a further approach, which basically administrator, whether those are DevOps admin or whatever you want to call them, I don't want to insult anyone, don't want to manage the storage via the storage UI. They want to treat storage just like electricity. And in the context of DevOps, it's just a line of code, just like they do for the compute, for the application that they are spinning up, for the networking part of it. Same goes for storage. For them, they want to consume storage as a line of code, and that's exactly what we are doing together with VMware. Why do they do it? Because they want it to be done in a very, very quick manner. They also want to be fixed on menu items, or as I call them, the hamburger menu. They don't want to have too many options because then it just further complicates things. And they want to be standardizing on specific ways of doing storage operations like the volume size, the QoS for a particular volume, and things of that nature. And the reason that they are doing it is that they can have a consistent result every time that they provision a volume or an NFS export from their underlying storage array. So it's easy to know and to expect what's going to be the behavior of the container running application, whether it's running in dev, test, or prod, without trying to debugging and troubleshooting the wheel every time that they're moving workloads from test and dev to say prod for that example. And into that came Kubernetes. So at the time, and even to this date, Docker can run on itself. It doesn't require Kubernetes. Docker can manage containers running on the specific bare metal or hypervisor that it is installed in. But what happens if you have more than one bare metal or an hypervisor server, say thousands of them, like we have with some of our customers? Docker do not have any sort of awareness to the other running servers in the infrastructure. And for that, you want to use Kubernetes. And Kubernetes, in a way, is the manager of managers, and in the context of the fact that it can actually know and understand the relationship between all the different servers that are running the Docker runtime applications. At the time, there were many other infrastructure managers and schedulers, as they may be called by some other people. Docker and Kubernetes, for that extent, has won the war. Even to this day, there are still some other infrastructure automation out there, but really Kubernetes has won the war for many reasons, by the way. I would argue that the main reason is actually not technical, it's a psychological one. Google were able for the first time to basically gather everybody and agreed on standards, which was lacking in the OpenStack days, but they're just my own opinion. In any case, Kubernetes has won the war in terms of schedulers, and one of the benefits that it's offering are things like scaling up abilities. Some next-gen database, like we're going to see in our demo, can literally be scaled when you need them in a click of a button, which was something that up until that time was like science fiction for that extent. So one reason why Kubernetes is heavily being used today, and it's the reason why VMware, before they started to develop TKG, Tanzu Kubernetes Grid, were actually decided on using Kubernetes as the fundamental management entity that will manage their runtime containers. I think now is a good time with the poll questions. So we've got a couple of poll questions for you. It would be great if you can answer the first two that you see. Feel free to answer them during the webcast as quickly as you can. First question is, which version of vSphere you are actually running today? In the past, some customers took them a longer time to adopt newer versions of vSphere. And the reason that we are asking it is obviously it's related to the discussion that we have today, because Tanzu Kubernetes Grid can run and support specific flavor of vSphere. So that's the first question that we want you to answer. And I think there is also a second one that you should be able to see now, that it would be great if you can also answer it during the session now. All right, awesome. So with that, let's move to the next slide. So how can a storage company like Dell EMC offer a persistent volume for their containers workload? Because when Docker started, they told everybody that they shouldn't care about data persistency and they should be building resiliency into the application itself. And when I heard it back in 2015, I remember I was scratching my head. I was like, oh no, not again. As a person who's been working in a storage company for the better part of the last 12 years, when a customer loses data, it's a very, very bad, awful day for that customer, no matter the reason. And so, building resiliency to the application is a good vision, but today, in the majority of the cases, Google said that more than 40% of their customers in GCP are actually running persistent container with persistent data, and the numbers is, by the way, just growing because it's much easier to let the underlying subsystem to handle all of those things, including resiliency. So if we're talking about resiliency, how can we actually provision a volume for the underlying running container? Well, the way to do it is to use the plugin called CSI. It doesn't stand for the TV show that is very familiar. It stands for Container Storage Interface. It's an API, again, invented by Google, but being developed conjointly with Google and the majority of the storage industry, not just Dell EMC, obviously, including VMware for that purpose. And CSI, the only purpose of CSI, the only reason that it actually exists is to provide this communicator, this manifestation that understands Docker on one side and Kubernetes, and on the other side, it understands the storage array. So for example, for operation like provisioning up a volume, mapping a volume, unmapping a volume, deletion of a volume, snapshot of a volume, all of those things are being called by Kubernetes to the CSI that needs to understand the underlying storage array. And every storage vendor is basically coming up with their own implementation of the CSI, and there is an exception that we're going to talk about in a second. So something to bear in mind. CSI, in most of the cases, is something that you need to download from GitHub, Docker Hub, for your specific storage array. And again, we support our CSI plugin for pretty much all of our storage products, all the major ones today that can do those things that I just mentioned before. With that, let's move forward into VMware TKG. So what's the big deal with vSphere 7, right? For many people, vSphere 7 is just another upgrade of vSphere that allow you to get a better E6 kernel, a better vCenter UI with the last final HTML5 UI. But actually, vSphere 7, if you think about it, has an underlying, much more important infrastructure. And that's for the first time, Kubernetes is deeply integrated into vSphere. How deeply? Let me give you an example. The reason that most of the customers don't run Kubernetes on just bare metal servers without an upper level orchestration on the top of it is that not only Kubernetes to install on day one is a hard thing to do, upgrading Kubernetes can be a very, very challenging effort, and I live to tell. So with vSphere 7, that was released back in May, it's literally a click of a button that, by the way, tells you that there is a new version that is available for Kubernetes and TKG. You click it, and then it upgrades your entire infrastructure. This type of simplicity was never done before. So that is really the big promise of vSphere 7 in the context of Kubernetes. Now, there are many names for that beast. Some may be familiar with the old name of that project when it was still relatively secret, known as Project Pacific. Some are familiar with it in the new name of like VMware Cloud Foundation, which is even an upper level management that Ian will talk about later on. And VMware call it today, when it comes to the Kubernetes part, the umbrella term is Tanzu. And Tanzu can have many services. The one that we are talking about is Tanzu Kubernetes Grid. And the bigger promise in that offering is the fact that for the first time, the vCenter admin or the vSphere admin or whatever you want to call it can actually talk to the DevOps person. Why is that a radically new, different type of thinking? Because a vCenter person knows to interface with vCenter via its UI, plugins, or maybe even CLI. But the Kubernetes administrator or the DevOps administrator, they don't know vCenter. The only tool, the only portal that they are using to manage their Kubernetes infrastructure is one command called kubectl. And kubectl can be expanded relative to what they are trying to do and relative to what other extensibility that they are actually installing to kubectl. So think about two people talking completely different languages, not understanding the other person's languages at all. And VMware, for the first time, was actually bringing everything together. So for the vSphere administrator, for them, containers will look just like another object in vCenter. And for the Kubernetes administrator, they can continue using kubectl with all the new offering and be managing VMs and containers from the same kubectl command. So that's a new radical way of doing IT these days that wasn't available before vSphere 7. So something to very, very important to bear in mind. Now, in the context of storage, which is what I'm talking about right now, there are really two ways that you can manage storage within VMware TKG. The first offering that is important to understand regardless is that when you are using VMware TKG, Tanzu Kubernetes Grid, we, Dell EMC, do not provide the CSI plugin for you. It's actually installed by VMware. It's a storage agnostic CSI plugin. In fact, you are not even allowed to install an external CSI plugin. So even if you will try to do it, it will fail with TKG. And then the storage vendor interface with the VMware CSI plugin in two options. The first option is the traditional VMFS option, which we're going to talk about in a second. And the more modern way to do it is via the vVols interface that are talking to the VASA provider on the storage array. Now let's try to understand what are the differences between VMFS to vVols in the context of Tanzu Kubernetes Grid. So first of all, where does the data live in the context of containers and VMware TKG? The container is just another VMDK file, regardless if it's on vVols or VMFS. It lives inside a VMDK format. Now, it's different than the traditional VMDK in the context of something called FCD, first class disk. What's the big difference? Traditionally, you would create a VMDK file when you provision a VM or you add a drive to that VM. FCD, a first class disk, can be created independently to the fact that you may created or not created a VM. So it can exist on its own, if that makes more sense. And now there are two ways that you can provision FCDs, dynamically or manually, also known as statically. If you do things in the manual way, let's discuss what you need to do. And if you do them automatically, let's discuss what you need to do. So in a manual way, VMFS, you need to create a VMDK. In many cases, the operator need to register the VMDK for the VMFS volume. And in any case, vSphere doesn't know to create a new VMFS data store for you. It can delete the VMDK files in some cases. It can create them inside of a VMFS data store automatically for you. But say you're running out of capacity on your VMFS data store, or maybe you want to even provision another data store, it will not do it for you. You need to go to the storage admin, or if you are the storage admin, you need to go to the storage array, provision a volume, format it as VMFS, and tell Tanzu Kubernetes Grid to use that VMFS as part of the pod. Not so efficient, right? So what is the more efficient way of doing things? Dynamically, right? Automated provisioning, which is done via vVols. The only thing you need to agree in advance is upon the storage class features. So for example, QoS mechanism, what should be the IOPS that I want to allocate for my gold versus bronze tier or versus silver, etc., etc. And then, which is the beauty of vVols in the context of TKG, it's all done dynamically for you. Once you set those policies, TKG is smart enough to go to your underlying storage array, provision a new vVol or more than one, obviously depends on how many data volumes you attach for the underlying running container. It will attach them, create them, map them. If you want to delete them, it will do it for you. Depends on the storage class policy, and it's all done completely dynamically for you. So let's see, which is a very common question, what happens if I want to have, say, more than one storage array in my TKG cluster? Is that even doable? So in this example, what I'm going to do is I'm going to use two storage products. To the left, you see our PowerFlex storage array, which is the new name for VxFlexOS. It's a relatively older slide. And to the right, you see our latest mid-range product that we just announced a couple of months ago, also known as PowerStore. Now let's assume, again, just for the sake of this example, I want to use PowerFlex for the vast majority of my running containers, which is fully supported configuration, by the way. And let's assume that I also want to assign a snapshot policy for that because it defined my gold policy within my infrastructure. So snapshots, the best performance, etc., etc. So the only thing I need to do is to create a storage class, attach it via VASA and vVol to vCenter, and call it something like gold, right? And then say that in my example, I want to use PowerStore for everything else, everything that, for example, doesn't require snapshots or replication or QoS, although again, they are fully supported. And in fact, the demo that I'll show you in a second is on PowerStore, but just again, for the sake of simplicity here, I'm using PowerStore for everything else, and I give it a silver storage class naming. Once those definitions has been agreed by everybody in the company, the Kubernetes administrator or the vSphere administrator only needs to remember this class definition. So at that time, when they will select gold, vSphere will be smart enough via the VASA and the storage policy-based management to go ahead and in this example, carve up the vVol volume directly from within PowerFlex. So super easy. The best way, again, to think about it for people who never tested CSI, and it may sound a little bit complex, you think about you running a restaurant of a fast food restaurant, right? You don't want to have 50 gazillions items because it's just going to make life miserable for everybody, including your audience. You want to have like 10 or maybe 12 items, and that's exactly what we are doing here. We create some very short, known, expected storage classes that everybody understands, and then you can, as a customer, go and give me this hamburger that has the gold storage class, which is exactly the case here. We have a predicted manner, performance, and volume size, and snapshots, and RPO, and all of those things that we know to associate with the workload that we intend to run with VMware TKG. Now, how does it look like? This is how it looks. This is how it looks like from within PowerStore. The upper screenshot that you can see here is how the PowerStore UI look like. So when using vVols, it actually is smart enough to take the container name and present it with vVols on the storage UI, so you can actually understand what containers you are running. And in the lower part side of the screen, you can actually see vCenter showing the storage policy that we just mentioned when it's connected to PowerStore. So you understand what is the storage policy that is associated with that Kubernetes pod, whether it's I, gold, silver, whatever you call it, with the whatever QoS, for example, mechanism that you want to surface. Two other screenshots. So one of the good things about PowerStore is also the ability to deep dive into each one of your containers, and because it's running on vVols, it will show you all the performance metrics for that particular container, which is a great thing when you're doing things with vVol because you don't have many VMs running like VMFS on the same volume. So the performance on VMFS can be relative to all the VMs that are running on that volume. Here, each container has its own vVols. So obviously, PowerStore will monitor and will show you all of this information for you. So the conclusion, if you are considering running VMware TKG, and I hope you would, it's a great offering, your first choice of using storage array policy is to use it with vVols. All of our main storage offerings are supporting vVols today, and somebody who's been working quite heavily on PowerStore months before its release, we optimize it to death when it comes to vVol optimization, especially around scale. People think that all vVols are born the same. That's absolutely not the case. A good POC to start with is to try to power up like hundreds of vVol-based container in one go, and that puts a huge burden on the VASA provider. That's a good way to test your storage array. And of course, it all holds true for the rest of our portfolio. So same optimization was done for PowerFlex, which we mentioned before, and of course our high-end product, PowerMax as well, which is fully supported with VASA and VMware TKG. I think now is a great time if we can show the other two poll questions, and if you can answer them, that would be absolutely awesome. With that, I want to jump to the demo, right? We've done the theory part, at least the high-level part. The first question is, are you considering to use TKG today? No, you know, try to be as candid as you can. That's I think very, very important. And again, relatively easy to use as well, relative to other offering. I think there is also another question that if, Julie, if you can surface it now, would be a great time as well. And with that, let's start with the demo. All right, so what we see here is the vCenter 7 with VMware TKG already installed on the top of it. And for the naked eye, hey, just like vCenter, right? Which is what we mentioned before. The first thing that we want to do in order to connect PowerStore with the VASA to TKG is to actually create a storage class, which we mentioned before. Remember the hamburger type of restaurant? So very easy to create one. You just click the Create VM Storage Policy, and you give it a name. That name can be any meaningful name that you understand what it means. It doesn't mean anything as long as you understand it. And you can see that because we installed the VASA provider, it's actually not an installation, just connecting it up to PowerStore, it's already surfacing the PowerStore vVol interface to TKG storage policy. And now, because PowerStore also support QoS, quality of service mechanism, we surface the QoS feature to vVol via VASA and SPBM, so you can use it when you're running containers. So the differences between high, medium, and low are the differences in terms of performance that you're going to get. Very similar to the VMware sharing concept, where if there is a contention, the container that has the high QoS will win over the medium and low, for example. We try to be very close to the way that your VMware administrator think about storage and VMs themselves. So I then connect it as the final step, and off you go. That's how you create a storage policy, storage class. And of course, you can create more than one. You can create another one called Silver and give it a low storage class policy for that matter. It's absolutely supported, and it's the reason why you can create more than one storage policy. The next bit is to actually create a namespace for the VMware TKG cluster. So I click the Workload Management tab, the cluster that you want to associate with the TKG, and click the Got It, and wait a little bit, and that's basically it. You know, I'm still amazed even today how simple it is to install Kubernetes when it comes to vSphere. The next part is to associate the storage vVols data store with that particular TKG cluster pod, if you will. So this is just what we did. You click the Add Storage, and that's it. You don't need to think about adding the storage as in the VMFS way that we did, that if it's running out of capacity, you need to reprovision one, because vVols in the context of data stores in the context of vVol are very different, right? You just create one data store, and then it can take the entire capacity of the storage array if you want it to. PowerStore, by the way, also have quota management, so you can actually limit the number of the capacity, the physical capacity for that particular one. All right, so I'm now switching that Kubernetes pod to the new namespace that I just created. And you will see here in a second that it's now showing the storage class that we did create for that particular vVol implementation. Remember, again, we do not install the CSI plugin. That CSI plugin is provided by VMware. We only answer with vVols and the VASA and the storage policy-based management. And now it's time to actually create our TKG pod in that regard. So I'm just going to create one using a YAML file. It's going to start installing everything for me. I now need to, as they say, sit down and relax. So let's fast forward it a little bit. By the way, you see little new icons that are new to Tanzu Kubernetes Grid. They look like a hive, I think. That's the right terminology, so you can distinguish them between traditional VMs or pods to, the Kubernetes ones for that regards. And now it's time to show you the NSX part. NSX is an inherent part of VMware Tanzu Kubernetes Grid. NSX, for those who are not familiar with it, it's the software offering by VMware that does network virtualization, just like compute virtualization is done by ESXi. NSX does it for networking. This is the PowerStore UI. Very, very easy to use. We worked on it quite a lot. As you can see, we have a virtual volumes tab that shows you all the vVols that are associated with the containers that you are running, which is in itself a very good way to distinguish your workloads on PowerStore. And you can see that there are various types of vVols volumes, which is exactly the point with vVols. Some volumes are the data volumes, some of them are snapshot volumes, some of them are the equivalent for the vSwap volumes, the descriptor volumes, and so on and so forth, which is what you see here. Now let's move it a little bit forward. What I'm now going to do is to spin up a new database. We love to test a database called Yugabyte that I'm not associated with that company, but it's a product that we use all the time because it's a true next-gen database that can actually scale out. You can literally click it, scale out, and it will create more nodes and divide the load between all of them. Think about Christmas time or whatever peak time that you need more database just for that period. Yugabyte is an amazing one for it. It's a transactional database as well. So that's the UI for Yugabyte, by the way. And super easy to scale, right? You click scale, and in return, what it will do when it comes to PowerStore and vVols, create more nodes on more vVols, divide the load between all of them, and off you go. So super, super easy to work with everything, literally within a click of a button. You don't need to think about too many things, which is, again, a radical new way of thinking when it comes to Tanzu Kubernetes Grid. All right, with that, I think I'm going to hand over to Ewing, who's our VMware Business Development Manager in our data protection solution, that is going to talk about protecting your containers data, which is as important as not losing your data. Kenon, are you ready?
I am.
Awesome.
Thanks so much, Itzik. Thanks for the introduction. And yeah, we'll talk about data protection for your Kubernetes workloads. So data protection inside of enterprise environments has been a trying conversation. You got your Kubernetes administrators who are moving very fast around development initiatives, driving new innovations for the company. And you have the IT operations that are responsible for managing the infrastructure underlying that Kubernetes infrastructure, right? This is the challenge that Itzik has been had kind of laid out in the outset of the conversation. And it doesn't stop at just the infrastructure storage component, right? It extends throughout the entire infrastructure, expanding out to networking and into even things like data protection. So as we have these conversations between the different personas in the enterprise about these applications and how they're moving and how fast they're creating content and applications and how we're managing them, a conversation kind of goes like this between the two teams. The Kubernetes administrator may say, we finally containerized our stateful application and we're kind of ready to put it in production. And the IT operator is focused on, is it ready for prod? Do I have a DR plan for it? Do I have the proper backup for auditing? Do I have cyber protection, compliance, and management? And it's not that I'm trying to slow down the progress or hinder the innovation, but as an IT operator, I have legal and functional requirements that I have to adhere to when it comes to data sets and application sets. And then generally the Kubernetes administrators around the space, they may have replicas they may say I have hundreds and hundreds of copies of this thing, or I've written some scripts myself, but that won't scale out to the enterprise. And they'll look to the IT teams for providing that infrastructure management, because historically, when it comes to applications, that's how it's been run in the enterprise, right? The infrastructure guys are responsible for the compliance, the management, the performance. And so these application owners are not focused on those areas. And that's where Tanzu Kubernetes Grid is trying to come in to simplify some of that activity between the operator and the developer. It kind of laid out, this is the fundamental premise of where we're going with Tanzu Kubernetes Grid on top of vSphere 6.7. And us as an infrastructure provider and data protection provider right behind that, we have the exact same approach on how we want to provide that management for the infrastructure teams. Sorry about that. I'm trying to go back one thing. There it is. We want to provide that enterprise-grade data protection, so we're not slowing down the speed of the developer. He can use native tools to be able to consume the infrastructure components like storage, as Itzik just showed us, and as well as data protection natively from his interface. But the IT operator still has visibility into what the developer is doing on the front end and can manage the infrastructure on the back end. So, we can ensure the infrastructure is performing up to par, and that we have the proper protection and guidance, compliance and governance associated with all the different data sets that are running out there. And we're using all the native Kubernetes tools, such as VMware Valero, to be able to implement our integrations into the spaces for these Kubernetes containerized workloads and the data sets associated with them. So our solution, PowerProtect Data Manager for Kubernetes, provides this infrastructure capability. And here's just a kind of a listing of some of the functionalities that you get out of the box. Things like protecting the entire namespace. So we'll talk about this a little bit more, but the data set is one portion of the application namespace. There's also the configuration and secrets and additional components around the Kubernetes configuration of the application that also need to be protected. And we'll talk about some use cases associated with those. But we also bring to the table the capability to do things like enterprise scheduling. Like you would think that would be so simple, just policy management and scheduling, right? We're kind of used to this in our enterprise world. It's just kind of baked into our infrastructure components of our backup software to be able to do scheduling and cataloging of the backup infrastructure. But we also provide that efficiency with our industry-leading platform, PowerProtect Data Domain, and bringing that power in our deduplication process into these next generation spaces, in addition to our capabilities with things like cyber recovery. So there's a myriad of different enterprise-grade capabilities that we're infusing into this application development and this new containerized Kubernetes-based workloads. So we kind of hit on these a little bit, but we'll do things like automate pieces of the process, like discovery of the Kubernetes cluster and all the services and namespaces that are running there, automatically deploying namespaces to facilitate the scheduling and backup processes, automatically deploying the data movement portions and containerized workloads to be able to do the deduplication and data movement processes. All that's automated and abstracted. So a lot of the complexity that a lot of customers have when they're trying to go down this space of containerized workloads and how to bring enterprise level management around those workloads, we've abstracted a lot of that complexity and really made it easy to be able to start accelerating what people are trying to do with these next generation solutions. And then it's all, again, everything that we do, you're going to be able to see it from the infrastructure perspective as well as from the Kubernetes perspective. And it's going to be native Kubernetes with REST APIs on the front end to be able to have a flexible way of how you want to consume the solution set. And it's important to talk about the different personas, because when we have a demonstration here in a minute, you'll see me kind of popping back and forth between the different administration UIs from the different personas. So you'll see the IT operator persona, you'll see the DevOps Kubernetes admin persona, you'll see the VM administrators persona. It'll be a little bit more clear once we get to that demonstration. But as we were talking about a second ago, Kubernetes is more than just the data set that may be associated with a persistent volume, right? There's deployments, replica sets, secrets files, configurations, and all of that needs to be protected as an entire logical entity. So we'll do that in with two different processes. One leveraging Valero to protect the application configuration names. So we'll protect the secrets file and the configuration map leveraging Valero, and then we'll leverage our PowerProtect namespace to facilitate talking to the CSI driver, as Itzik was talking about, to be able to facilitate the snapshot of a data volume, and then we can deduplicate that data and send it over to our protection storage mechanism. But all of that will be protected as an entire logical entity. And when we're talking about the integration and the different personas, you can see here the IT operator has full visibility into what's happening from the infrastructure perspective. So we can see all of the namespaces, what are the policies associated with them, when was the last time the policies were functioning, do they have successful backup? And then the DevOps administrator has the ability to be able to consume those things natively from the front-end interface. So he can apply protection policies to namespaces, change the protection policy from one to another, and do restore operations directly from his command line interface. Just waiting for the slide to update. We got a little delay on the slide update, so sorry about that, guys. And then when we talk about VMware Tanzu and the specific implementation for TKG, we were talking about the first class disk, and it's under the cloud native storage implementation from VMware. Again, the first class disk is VMware's iteration of the CSI driver. So when we're looking at this, you can kind of see there's an additional persona in the Kubernetes environment, that being the VMware administrator. But outside, so the only thing that's different with our implementation for Tanzu is the fact that we're leveraging the fact that the disk volume for the persistent volume is a VMDK, and all of the benefits of VADP from a backup perspective are applicable to that workload. So we get an optimized data path for that backup workflow that we don't have the capability to get with any other CSI driver on the marketplace. And it actually is important because it actually drives a pretty significant performance gain through that optimized control path. Here you can see on the left, we've done a backup of a workload using the native CSI driver, and the full snapshot size was 108 megabytes. But on the right side, we leverage vSphere 6.7 Update 3 and the cloud native storage implementation for first class disk. That allows us to take a VADP snapshot of the VMDK, taking advantage of things like change block tracking for the backup. So when we take the next backup of that workload, we're actually only backing up 76 additional kilobytes. And then we're taking that 76 kilobytes and compressing and deduplicating that down even further, and then sending that over to the protection storage. So you can see how that's a significant decrease in the amount of capacity that we have to even scan through to facilitate a backup, leveraging all of the benefits of change block tracking in VMware that we've been leveraging for a number of years for virtual machine protection. We're just extending that capability into these next generation workloads with containerized workloads running on top of VMware 6.7 Update 3. And with our newest release of our solution, we actually introduced some net new capabilities that are really attractive in these next generation capabilities. One use case being we can take a Kubernetes namespace and through our backup capability, restore that namespace to a different Kubernetes cluster. This is extremely helpful if you're trying to move from one Kubernetes cluster to a next. There are use cases where people do not upgrade their Kubernetes cluster. They'll install a new version of Kubernetes and then redeploy the namespace on top of that new Kubernetes cluster. We can help facilitate all of that associated with the data and the configuration of that namespace to seamlessly move it from old cluster to new cluster. Or if you wanted to go from your dev environment to prod, this just provides the easy way to go from point A to point B very seamlessly, or from on-prem into a cloud Kubernetes cluster. So very flexible in the way we can move the data around. Another capability that we introduced was the ability to do application consistent backups for MySQL and MongoDB. So this is actually an industry first to be able to leverage a agentless architecture, meaning that it's still leveraging a Kubernetes declarative kind of configuration to be able to describe the state of the protection associated with the workload. And then we can take an application consistent snap by leveraging quiescing the application state, backing up the data, and then unquiescing it after we've got a clean snap. And this supports both the traditional CSI or VMware CSI driver with first-class disk. So a very innovative capabilities that we're bringing to bear for these workloads to be able to provide data protection. So here we have a little demonstration of what it looks like. This is my PowerProtect Data Manager interface. You can see I have a PowerProtect data domain already discovered. And if I go to add a Kubernetes cluster, I'll go discover a new cluster. I put in the IP address. I have to provide an authorization token. So I will pop over to my Kubernetes administrator and ask him for that authorization token. And he'll pass that over to me. So now I have my Kubernetes administrator hat on, and I'm getting the authorization token to be able to provide the infrastructure team to be able to interact with the Kubernetes cluster. So I'll pass that back over to my backup administrator. He'll put that in his configuration and verify the certificate associated with the Kubernetes cluster. Once we've done that, we've successfully discovered the Kubernetes cluster. We'll crawl it and discover all of the namespaces that are running on top of the Kubernetes cluster. Now we can see all of the different workloads that are actually running there. So let's take a look at a namespace that we want to protect. We can see that there's 3 persistent volumes associated with that workload. And now I'll pop over to my Kubernetes interface, and I'll check the details of my nodes, my Kubernetes nodes. I'll look at all the namespaces on my Kubernetes cluster, and you see I have the one that we just saw from my PowerProtect Data Manager interface. I'll look at the containers inside of that namespace and see 2 containers. I want to see what storage is associated with those containers, and I can see 3 storage volumes. Let's see what the CSI class for those storage are. So I see 1 CSI for Ceph and 1 CSI driver for VMware. Now, if I attach to that Kubernetes container, I'll be able to see the data that's associated with those persistent volumes. So let me attach to one of those, and I can see, oh, I got some HTML. Let's see what's inside of those. Just some Nginx, just some generic data from a web perspective. Okay, cool. So I have the 2 containers in this one namespace with 3 PVCs that I'm gonna try and back up. Now you see I have the PowerProtect and the Valero namespaces that were automatically installed once I discovered the Kubernetes cluster. So now I'll go create a protection policy as the backup administrator. So I'll say, okay, let me create a name. I'll make it Kubernetes, make it crash consistent, and then I can pick which namespace I want to do the protection for. So I'll search for it here. And again, once my policies are created, you can make the association to them from the Kubernetes interface as well. So I'll protect all 3 of those PVCs. I need to create a backup schedule. So every 2 hours, I'll keep that for 1 day, and start time, end time. All right, so now I got my backup configuration all in there. Let's go look at the jobs that are running. So now I have a running configuration job, okay, that just completed. So now I've done the configuration and extended the data protection declarations to the Kubernetes configuration. And you can see I have a protect job running. So now we're actually facilitating the protection of the namespace. So we were talking about vSphere 6.7 update 3 with those cloud native storage first class disks. You can see those here. So you can see I have a number of volumes associated with containerized workloads. I'll pop back over to my Kubernetes interface. And now that the backup is running, let's see what's happening inside of the namespace. So now if I look at the pod, the containers inside of the namespace, you'll see I have an additional container, the C proxy, and that's automatically deployed when the backup starts to facilitate the data movement. So that has our deduplication process to be able to deduplicate the data before it's transmitted over the network. So you see here, we're talking, because again, this is happening to a first class disk. We're actually taking a VADP snapshot on the back end associated with the protection of the containerized volume, even though it's a CSI workload on the top of it. So we'll give a couple of moments here to allow that data protection to protect all the configuration, all the secrets, and all the persistent volumes associated with that namespace. All right, we got a successful backup. I can see the details associated with the backup here as the IT administrator, but I can also see the details as the Kubernetes administrator as well. So if I go look at what completed jobs, you see I have my configuration jobs done, the protect jobs done as well. Now I check the containers. Now my proxy is no longer running because the backup is completed. And just like I could check the details as the IT admin, I'll check the details from the Kubernetes administrator's viewpoint. So I'll run the command that I need to do to see the actual details associated with the backup that we just ran. So now I see, okay, I see the last time that my specific namespace was backed up, and here are all the details associated with that backup. I can see it in the manifest. See all the associated JSON configurations for Valero. I can see the associated VMDK backups for the persistent volumes, and I got a good copy of my namespace. Excellent. So with that being done, let's go look at a restore process. So I'll go into my backup administrator and want to do a restore. I have a couple of options. I can restore to the original or an existing, but I'll choose to restore to a new namespace. And I can pick the persistent volumes that I do or do not want to associate it with the restore. I'll bring them all back. So I can look at the details and kick off the restore job. I can see that running here from the backup administrator's interface. If I go back over to my Kubernetes administrator, he'll see the new namespace being created that we just facilitated as a part of the restore. And if I look inside of that namespace, I'll see a couple of containers running, one for each different type of storage that I have out there. So I got two different proxies that are restoring the data. And then you'll also see what storage volumes we are. You see those 3 storage volumes, and we're bringing those back. You'll also see the corresponding VMDKs associated with the first class disk being created inside of the vSphere interface as well. So again, all this is happening in real time through all the different administrators' interfaces, and everybody knows what's going on inside of the infrastructure. The vSphere admin knows what's going on, the Kubernetes administrator knows what's going on, and the backup administrator knows what's going on. So we'll give a couple of moments to allow that restore job to complete. We can see the details. And you can see I have all 3 of my persistent volumes have been successfully restored. So if I pop back over to my Kubernetes interface, we'll see that the proxies are now finished with their restore job. They're no longer inside of the namespace, and I can attach to the containers that were restored. And then I can look at the disk volumes that are associated with those restored containers. All right. There we go. So if I look at the storage, I see the HTML2 and HTML1, and I see all the data that was associated with them. So our restore is all done. But you can see it's very easy to integrate between the infrastructure, the vSphere administrator, and the backup administrator, all live and in real time. Thanks for your time.
Awesome. Thanks, Ken. So I just want to answer one question that I saw in the Q&A. The question was, so none of these automation is possible if you are not using supported external storage source that supports vVols. Yes and no. If you are not using VMware TKG and it's plain Kubernetes or maybe some other offerings that is not using VMFS and or vVols, in most cases bare metal servers, then CSI that we provide you, the customer, will go ahead and create raw volume. I mean, just think about them just like volumes, and map those volumes, unmap those volumes, delete those volumes automatically for you. But in the context of VMware TKG, you have 2 options. VMFS that needs to be re-provisioned in advance, and the only thing dynamic are the deletions of the VMDKs and the creations of them. But it will not go ahead and provision VMFS data store for you because that's not something vCenter does. But if you're using vVols, then of course you need to create only one data store, and then the vVols are the dynamic entities. So in any form of shape, it's fully automated for you. So those are really the options. Right, so before I move the ball to Ian, again, I just want to conclude the first part of this webcast. This is a journey that started a couple of years ago. In fact, back in 2018, I was participating in a customer advisory board, and people told me after I presented the CSI interfaces that we just started to work on it a couple of years ago. They were like, "Great, what about backup and restore?" And I was like, "Wow, a couple of years ago, people told me that they don't even care about persistency of the data, and now not only that you care about the data, residing on the storage array itself, you also care about the backup and restore." So, it's a journey that started a couple of years ago, and I'm really, really proud that we as Dell EMC together with VMware can really bring it all together. Not just the compute part, not just the storage part, the entire ecosystem around it. For me, there is a screen in the PowerProtect UI that shows you Kubernetes. It's just another use case. It's a very compelling use case. It's the hottest trend, everybody talking about containers these days. But if you think about it, it's yet another use case that you want to protect, just like you want to protect your physical servers and virtual machines, and God forbid, even mainframes. It is just another use case, and you want the entire ecosystem to basically be supporting it, from storage to data security, for data backup, etc., etc. So this is why I'm really proud that we were able to bring it all together in the last couple of years when we worked around supporting the entire ecosystem. So with that, I would like to transfer the ball to Ian. Let's see. Ian, you should have the ball right now.
You can hear me?
Yes.
Excellent. Great. Well, good morning, good evening. As Itzik said, I'm not quite sure where you folks are, but welcome. Let me just turn on my webcam. So today I'm going to talk a little bit about VMware Cloud Foundation and external storage platforms. And my goal is for you guys to be informed about VCF and Dell technologies and how it can impact you in your role. Prepare you so you can understand what's required for VCF and Dell EMC storage deployment. And in addition, where there are questions or questions I can't answer, we'll park those and I will get back to you either at the end of my talk or in a follow-up. So I'm Ian Breitner. I'm part of the storage solutions team at Dell Technologies, and I focus on VMware as it pertains to our storage platforms. I've been involved with VMware since vSphere 4 days, so quite some time. And as I mentioned, I'm going to be talking about VMware Cloud Foundation and our external storage platform. So let's get started. So why is VMware Cloud Foundation important? And it's come as a result of customer feedback. And what we're hearing from our customers, they have three main strategic priorities. They want to empower digital workspaces. So customers are building new models for employee access to data and information. They want that to be across any device. And the second thing they're doing is they're transforming networking and security. They're responding to demands for new applications and services, but these demands are exhausting the capabilities of traditional networking architectures. Customers want to move from a data center-centric model to a new architecture that supports centers of data, either in the cloud or at the edge, or indeed in their data centers. And the last one is they want to modernize their existing data centers. Every single one of our customers still sees significant upside within their data centers. They're highly virtualized, running some of the most business critical applications. And the customer's goal here is quite simple: bring increased efficiency and obtain the most out of their existing investments. But at the same time, I'm going to say leverage cloud, so we'll talk about that as we go on. I want to spend a second talking about VMware's vision. Their vision is to provide customers the ability to deliver any application on any device via any cloud. Now, there's a couple of unsaid things in there. Any cloud meaning hybrid clouds, that is on-premises data centers, and other types of cloud offerings, public clouds perhaps, telecom clouds or edge computing clouds. But they want to be able to deliver this regardless. And Dell's vision is also to provide a unified approach, integrating from data center to devices and enabling the delivery of digital workspaces that allow end users to safely consume the applications and content that they need on any device. And both VMware and Dell Technologies Foundation is built on an integrated architecture for the data center, for the cloud, and provides both cloud native, traditional, and SaaS-based application deployments. So one of the things that's important here is common infrastructure, common operations, and intrinsic security, no matter how you actually are providing access to the applications for your end consumers. They may be your customers, they may be your employees, they may be your contractors and partners. You still need to be able to manage this in a very efficient fashion. So what does it mean to have a cloud operating model, and how do you get there? So our customers are spinning up workloads in the cloud, and perhaps I should say here in the public cloud. And what our customers are telling us is that they're not comfortable with some of the constraints around security, performance, or even lack of control of their workloads in the public cloud. And surveys conducted by ESG and IDC show that customers only always want to plan that their data centers are part of their transformation, but some of the workloads that they will have moved to the clouds or had moved to the clouds, they want to repatriate those for a variety of reasons and run those in the data center. But the point here is that the data centers are still part of their transformation plans moving forward. And I guess it's no secret, customers are paying a premium for the convenience of public cloud offerings. What they really like out of those public cloud offerings is the flexibility, the cloud operating model that you get. They like being able to spin up workloads on demand. They don't have to manage complex change control. They like the consumption model. So there is a lot to like about public clouds. And from our perspective, the software-defined data center is the cloud operating model that our customers want. The software-defined data center virtualizes and abstracts all components of hardware, excuse me, in the data center. That's compute, storage, networking, and security. And it runs across premises and into hybrid cloud environments. Customers are looking for a platform that is highly automated to deliver the outcomes they want quickly and seamlessly. And it's addressed by this software-defined architecture. Now, developers and consumers are looking for an all-encompassing solution as well that's focused on provisioning new services quickly, and they're less interested in the infrastructure itself. They just want things to work. And they expect the infrastructure, whether it be on premises or in the cloud or at the edge, to support their business workloads and simplify the decision they have to make about where best to place those workloads. Customers are also looking for flexibility to move their applications and services seamlessly when required without having to make any slow and complex changes. And that's actually something that's fairly difficult today. If I want to move a workload from my on-premises infrastructure up into a cloud of choice, usually it's not just, oh, I just moved the workload. I need to actually make some significant changes. And then once I get it into that location, if I then decide to change my cloud of choice to a different cloud of choice, I have a rather large lift to go. And then bringing things back into my on-premises data center may not be so easy as well. So which brings me to VMware Cloud Foundation. So this is the hybrid platform for managing VMs and orchestrating containers. And it's built on a full stack approach. It provides a single architecture that's easy to deploy, and VMware Cloud Foundation enables a consistent, secure infrastructure and operations across public, private, and edge clouds. And it increases the enterprise's agility and flexibility with the hybrid cloud that it delivers. VMware Cloud Foundation allows the provisioning of infrastructure from a pool of virtualized resources on premises, at the edge, or in the cloud, and provides automated deployment of Horizon 7 virtual desktops, allowing standardization and automation, and simplifies the virtual desktop experience. VCF also allows the deployment and development of modern applications on premises or in the cloud through VMware Cloud Foundation services. And that's a new integrated Kubernetes and RESTful API surface. And we'll talk more about that. In fact, you would have heard Itzik and Kenon already talk about some of that. VMware Cloud Foundation uses VMware vCenter Server for virtual machine and container management, monitoring, and provisioning. So I mentioned before, VMware Cloud Foundation, it's built upon a standardized architecture, which is outlined in VMware validated designs. It's a full stack approach. It's simplified operational experience for how you deploy and manage your deployments through day 2 operations. And it does include lifecycle and capacity management. The platform is tested and validated by VMware and its partners. And VCF is heavily automated, which simplifies VM and container management in terms of deployment, expansion, and as I said, day 2 operations, and patching and updates. It allows customers to consume infrastructure through upstream self-service portals and blueprints and public APIs. Security is built into every layer, from the hypervisor to storage to networking, and with the option to migrate across into public cloud environments that can scale to meet the needs of your business. And Dell Technologies and VMware have invested heavily in building a cloud foundation platform that brings together all of these technologies across compute, storage, networking, and management. I want to take a second and talk about SDDC Manager. SDDC Manager is unique to Cloud Foundation, and it is what differentiates Cloud Foundation from the build-it-yourself SDDC and VMware validated design deployments. SDDC Manager is a tool used for automating deployment and scaling of workload domains, and I'll explain what that means in a minute. It also manages patching and upgrading of the whole VMware stack, and in some instances of the hardware infrastructure as well. So VMware Cloud Foundation introduces a new abstraction, virtual infrastructure or VI domains. And these are also known as workload domains. And basically these domains are containers, resource containers with specific policies regarding performance, availability, and security. There are two types of virtual infrastructure domains, a management domain and multiple workload domains. And there is also a special workload domain that's intended for VDI deployments. VI domains consist of one or more vSphere clusters that are provisioned automatically by the SDDC Manager. There are logical SDDC instance of one or more vSphere clusters with a dedicated vCenter server and NSX Manager, and both of which, the NSX Manager and the vCenter server, they're located in the management domain. Now, there is only one management domain per VCF deployment, and it's created during the initial VCF setup process. It does contain a vSphere cluster and at least one vCenter server, and multiple platform services controller plus NSX for vSphere componentry, and also some vRealize suite components. The other workload domains, other VI domains or workload domains, and I'm going to distinguish between that. So VI domain covers everything, but a workload domain is the domain where you can run multiple vSphere clusters. You need a minimum of 3 hosts, a maximum of 64, but these are the ones where these workload domains are where you actually run your application suites, and we'll talk about that again as we go on. When VMware Cloud Foundation creates and provisions workload domains, it deploys a dedicated vCenter server, as I mentioned, located in the management domain, and it also deploys NSX for networking in the workload domain. When you're deploying a VDI workload domain, VMware Cloud Foundation deploys the VMware Horizon infrastructure required to support the VDI environment. It first provisions the VDI workload domain and then deploys and configures the Horizon stack in that workload domain. And the VDI workload domain contains other software components as well, things that support the VDI domain, like View Connection Server, Horizon Agent, Horizon View Administrator, and View Composer. Now, Cloud Foundation will support a total of 15 workload domains within a single deployment. Each vCenter server deployed within each workload domain is configured with enhanced link mode, so they all share a common single sign-on domain. Let's dive down a little bit into the storage. As I mentioned before, you can have multiple VI domains, the first one being the special management domain that's created, and the one that houses all the vCenter servers that are managing the various workload domains. Apart from the management domain, the various workload domains can be provisioned with various storage offerings. The initial storage that's provided in a VI domain is termed principal storage, and any subsequent storage platforms or any subsequent storage that's included in those workload domains is called supplemental storage. Now, the only difference between these two is the nomenclature. Principal means it got provided first. Supplemental means it came after. The storage platforms themselves offer exactly the same functionality. There is nothing different as far as that's concerned. Now, by default, when VCF does deploy workload domains, vSAN is the default storage offering, but it doesn't have to be that. You can select whatever storage platforms you may like as your principal storage. It might be NFS, it might be iSCSI, it might be VMFS, or vVols, and typically people are starting to use vVols because of some of the advantages that vVols provide. And when you do deploy your first VCF environment, that is the management domain, by not only by default, but vSAN must be the storage offering that's used there. Yes, you can add other supplemental storage if you need. Typically what customers do, and we'll actually show some architectures as we move forward, what you see when you deploy a VCF workload domain is you'll see your management domain there, but then you can actually have whatever workloads you need in your workload domains with the storage platforms that make the most sense for what you need to do. And I do want to point out that when you are deploying Dell EMC storage platforms within your or to your workload domains, a single storage platform such as a PowerMax can support multiple workload domains. Either they can be there as principal storage and then add in additional storage for supplemental storage, or the storage platform can support multiple different workload domains simultaneously. So I could take, for example, a single PowerMax, and I could have it support 3, 4, 5, up to 15 workload domains to the limit of the VCF constructs. And it all comes down to what should I do? It depends on the storage requirements and the I/O requirements that the applications that are running in those workload domains require as to what you would do. So here's an example of what a VI infrastructure or a VCF infrastructure might look like. I have my hardware pool down the bottom where I have both my servers and my storage platforms. And that could be a HCI or a converged infrastructure platform as opposed to just discrete componentry. The choice comes down to what works for your customers or your environment, specific workloads that you have. But you can create these different workload domains. And so I could dedicate one to my, for example, my SQL Server databases. I could have my Horizon VDI environment provided. I could actually then have something, a generic infrastructure workload domain that I have, or my container workload domains. I can do whatever I need. And the reason for partitioning this way is easier management, better control of what's going on in my environment. I want to talk a little bit about how Dell Technologies Cloud plays a part in this, and Dell Technologies storage platforms are part of Dell Technologies Cloud. The reason that we have Dell Technologies Cloud is to bring together Dell Technologies infrastructure leadership and VMware software-defined offerings. And this provides a range of offerings, levels of services, performance and scalability needs for meeting the tailoring to the needs of customers' business deployments. And there are two main components to Dell Technologies Cloud. And both of these combine, so we actually have one cloud experience for all of our customers. So you can either modernize your existing infrastructure, or you can actually transform to a complete cloud operating model. And by the way, it's not an either-or conversation. It's usually we need to do both. So I need to run my private cloud in my existing data centers. I want to extend to the public cloud for certain functionality that public cloud provides. And I will eventually be including edge data center requirements. So I might have remote offices. I might have specific needs for example, if I'm in the healthcare industry, I might be supplying electronic or technology components to hospitals and to clinics that would be considered an edge environment. So I mentioned before, we have a number of components that go together to provide the Dell Technologies Cloud, a combination of Dell EMC infrastructure, VMware Cloud Foundation, and a variety of partner clouds as well. So let's take a little closer look at some of these things. One of the things that we're doing with this is to provide workload mobility with a single control plane, no matter where you are going to be running your workloads, in your core data center, in the cloud of your choice, or out at the edge. And there are three ways to consume VMware Cloud Foundation with Dell Technologies Cloud. One is through a platforms operation, and we'll talk about that in just a sec, through validated design or I don't actually have to manage the thing. I would like for you to just simply provide for me a complete service offering that provides me a data center as a service. So actually, let me just go back a second. So the platforms we have are both hyperconverged and converged infrastructure platforms. You may have heard of this as VCF on Dell EMC or VMware Cloud on Dell EMC. That is actually our VxRail offering that's integrated with VCF. So you actually get what I'm calling a cloud in a box. It combines all of the necessary components from VMware, the infrastructure components from Dell Technologies, and all the services needed to actually deploy and train your IT staff to go and actually manage this cloud environment that you have. And yes, you can buy that as data center as a service. That's exactly what that would be. The value of this is that within a week, you can actually have a complete VCF cloud environment up and running in your data center that actually is providing workloads to your specific application needs, whether it be container modernized application software development, or I just want to migrate my existing virtualized applications into a cloud operating model. Most of our customers actually wanted to do a little bit more than just what HCI and CI provides. HCI is constructed of regular building blocks. So every time I need to increase capacity, I increase both servers, that is my compute, and my storage by identical amounts. But some customers actually want to be able to do this independently. I want to be able to scale my compute independent of my storage, and that's where these validated designs come in, where you can actually choose the componentry that makes sense for your application needs. Whether I'm going to be using a specialized high performance storage platform like a Dell EMC PowerMax, whether I want to use something like a blade server system like the PowerEdge MX, or whether I just want to have a mid-range scalable storage platform, I can get this through Dell Technologies Cloud Validated Designs. And you will notice that in the resources section, I actually have provided a PDF document about the cloud validated design, both best practices and exactly what that's all about. So let's talk a little bit more about the storage platforms that comprise the cloud validated design that are integrated into VMware Cloud Foundation deployments as both principal and supplemental storage. So I'm going to start with the Dell EMC PowerMax. It's the world's fastest storage array with extremely high throughput and low latency. In fact, it delivers sub 100 microsecond read latency, and it scales up to 4 petabytes of effective capacity. PowerMax runs end-to-end NVMe and provides up to 15 million IOs per second, and those with sub-millisecond latency. So reads are sub-microsecond latency, and reads and writes, the mixture is sub-millisecond latency. In fact, if it's more than 1 millisecond latency, we typically are not used in those environments. In fact, I don't think we've ever come across that, by the way. We also have a new mid-range platform, the Dell EMC PowerStore. And this is a rather interesting platform. It's a scale up and scale out storage array. It's built on a containerized storage operating system with each PowerStore array scaling up to 2.5 petabytes of effective capacity. And you can cluster up to 4 PowerStore arrays together. And PowerStore also comes with a new feature called Apps On. And this allows the running of VMware virtualized applications on the storage array itself. So you've got the storage, and you are now running the applications on the same physical array. And this provides for some interesting use cases. And by the way, if you are interested in some of these use cases, I would highly recommend that you attend this year's or register for this year's VMworld. And there are a number of sessions on healthcare around PowerStore and the value it brings to a hospital environment. PowerStore also provides guidance for where workloads should be placed. So the initial placement of the workload, it will recommend a location for that to be placed. both in terms of the storage and the performance and the application performance. And it will also constantly monitor what's going on, and if workloads need to be rearranged, it will provide guidance on that as well. So it provides a way to balance out the workloads you've got. It also provides for operator controlled migration. So if you're being told that this particular section of the storage is starting to actually get more IOs than you have elsewhere, you might want to rebalance the storage, and it will provide for those migrations for you. The Dell EMC PowerMax and PowerStore arrays are ideal for applications with demanding throughput and capacity needs, and they deliver the flexibility to scale independent of compute for greater performance and application flexibility. And customers can build new levels of storage resiliency with synchronous replication for disaster recovery purposes, from on-premises data centers to multiple locations. All of these storage arrays actually integrate with the vRealize operations suite, and Dell provides VRO plugins where administrators can take advantage of the VMware tools of choice for deployment to stand up new environments, to attach additional storage components to their VMware infrastructure. And customers can schedule things like storage operations like provisioning storage or scheduling snapshots directly from VRO. They can also further automate storage management activities by establishing workflows through VRA. But that's not the only storage platforms we have. Also available, part of the validated design, is the entry-level PowerVault and the mid-range Dell EMC Unity XT storage platform, which offers both block and file storage. And then, not to forget, we have PowerFlex, which is a software-defined array that can scale both compute and storage independently and can scale to thousands of nodes. And if you'd like to learn more about these storage platforms, you can go to delltechnologies.com/storage to find out more about them. So why do customers need different storage options for VCF? There are different workload types that customers have. They may have ones that utilize large data sets or have specific IO requirements that storage can provide for those specific needs. And examples of these types of workloads are databases or big data sets. And the data sets also influence the ability of where applications can be run. Data sets have something I call data gravity. And the larger the data set, the greater the gravity, and the harder it is to run the application in any random location. Moving the data to the compute requires a lot of bandwidth, and leaving the data in its current location to be used with compute being in some other location can and does lead to latency issues. And in fact, it can actually result in the application failing to operate at all. Moving the complete data set into a public cloud is both time-consuming and expensive. And what do you do when the data needs to be repatriated? It can be extremely expensive. That's not to say I don't have customers that have done that. I actually have one that's moved petabytes up into a public cloud. That's their permanent location for that. But most of our customers that have actually taken advantage of public clouds have looked at the value that they're getting, the management challenges they have, and have decided to repatriate certain workloads back to their on-premises data center, which they are modernizing. If I want to deploy and use a hybrid cloud, I still need to ensure consistency between my on-premises data sets and those used in my public or private cloud. And to address this, Dell EMC offers Dell Technologies Cloud Storage Services, which allow a customer to select the data sets they want to be replicated to an identical storage array close to the desired compute infrastructure, AWS, Azure, whichever. And those data sets can be exposed to the cloud of choice's compute when required. So I'm not actually paying for any compute until I decide I need to use it. And yes, I am paying for the additional storage that I've got in my remote location, in my replication location, but I'm only paying for the amount of storage that I'm consuming rather than for an entire array. And by the way, the storage platform, the storage data that gets moved up into this cloud storage services location can be exposed to many clouds simultaneously. And the data sets are actually replicated at the storage level. So your on-premises storage array is replicating to the cloud storage services equivalent array, and then when needed, it's exposed to the compute platform of choice. You can also configure these things for disaster recovery purposes. And in fact, we have a number of customers that are doing exactly that. And you can have this to a customer's secondary data center. Our larger customers tend to have multiple data centers, or to a DR colo location, or to something like VMC on AWS. And this latter one is a very common use case. Once a customer is invested in their storage platforms for their VMware environments, they still want to leverage that. They want to be able to utilize those storage platforms with their VCF deployments. The data sets they've got on those storage platforms, they're not throwaway things. They don't necessarily want to migrate them. They want to continue to use and leverage those storage platforms, principally because of the unique value those storage platforms are bringing to those customers' VMware environments. So one of the reasons for keeping the external storage platforms is I can actually plug them into my VMware Cloud Foundation environments, whether it be VMC on AWS or VMC on one of the other hyperscalers, or whether I'm doing it in my own VMC private data center. I can bring those storage platforms in either as principal, the first one introduced into a workload domain, or as supplemental, subsequent introductions into those workload domains for consumption by the applications that I am running in those environments, whether they are existing applications or net new ones that I'm developing. So Itzik and Kenon talked about modern application environments. I just want to touch on that finally. And you've seen this before, but the question that comes up is, do I need to do anything special if I'm using my existing Dell EMC storage arrays and I want to use them with VMware Tanzu or TKG, TKGI? And the answer is no, you don't need to do anything special. We support running TKG workloads on our storage platforms, whether they be using VMFS, NFS, or vVols. It makes no difference. We support them all, and they require no special plugins, no special changes. If they're plugged into your VMware environment, they will just work for what you're planning to do with Tanzu. And whilst they just work, there are some integration options, and I kind of alluded to them before. We support VMs, we support Tanzu, we support containers, so that doesn't have to necessarily be through the TKG environments. We support those on our storage platforms, but we also integrate into the vRealize suites through VRO plugins, VRA constructs, and through VCF. And all of these are supported by the plugins are supported by Dell Technologies or Dell EMC. So VRO, VRA, VCF. They come from, the support comes from Dell EMC. And we validate and test these things before we actually release the products to support these. So let me talk a little bit about what does a typical hardware deployment look like. So let me just build this all out. The first thing that happens when you deploy VCF is you get a management domain that's created. And as I mentioned before, by default, it's running vSAN. Well, actually not by default, it can only run vSAN as principal storage. So that gets deployed. The next thing is that we'll actually deploy a virtual infrastructure or workload domain for some specific workload type. Maybe we'll deploy a second one. So here we've actually got examples of deploying these workload domains using Dell EMC PowerStore, Dell EMC Unity XT, where we're actually running NFS, and the initial one using Dell EMC PowerMax for what we need to do. Oops. These architectural components can scale out up to the maximum needed for, or a maximum allowed for any VCF deployment model. So that is up to 15 virtual infrastructure or workload domains. If that is insufficient, then you have a second VCF deployment. Now, one thing I mentioned is that some of the VCF or SDDC value is that it not only maintains the VMware componentry and keeps that up to date and does not allow you to get into a position where you might upgrade one component to discover it is incompatible with some other parts of your VMware ecosystem. It ensures that when an upgrade occurs, it occurs in a consistent fashion. And I also mentioned that can actually include the hardware in some instances. And so this goes back to VMC on Dell EMC or VMware Cloud Foundation on VxRail. In those instances, not only does SDDC Manager maintain the latest versions of the VMware componentry for you, it will also maintain the latest firmware releases for the VxRail componentry that's in place there. So it truly provides a complete automated environment for you. So with that, I would like to thank you for your time. And if there are any questions, I'm more than happy to take them. And just before everyone goes, I'm really curious to know how many of you are actually using VCF today? So the responses are slowly coming in, and it looks like the majority are not. I'll give it a few more seconds before I actually show the responses to everybody. So the answer is about 10% of you are using VCF today and the rest are not, which is interesting because VCF does provide an easy way to manage your VMware deployments. And yes, I know you can't actually retrofit it to what you've got in place, but you actually do need to start with a net new deployment. So that's very interesting. But with that, I would like to thank you for your time. If you have any questions, feel free to put them in the Q&A box, and I'll be hanging around for a while to answer those questions.
While we're waiting for questions to come in, I just want to take the opportunity to say thank you to all of our speakers for taking the time to speak to us today. As a reminder to the audience, you will receive a follow-up email with the on-demand link from today's webcast. To find out more about the VMUG webcast program, visit vmug.com and check out the education page. And please make sure to complete the short online evaluation that will pop up as you exit the webcast and let us know how today's session went. And from all of us here at VMUG, thank you and have a great rest of your day. Ian, I'll give it one more minute for questions. Okay, I don't see any questions coming in, so I'm going to go ahead and end the webcast. Thank you again, everybody.
So hang on a sec. There's just one question.
Okay.
I just want to, I want to answer it before. Okay, that was the last question.
Okay. All right, great. Well, thank you all so much and have a great rest of your day.